Hey kids, this is Mr. Cozy, and I am here to tell you about the real number system. When we talk about sets and containment, the real number system is a really easy, accessible example of how these ideas fit together. So let's go through the parts of the real number system. Where we start is the natural numbers. The natural numbers are the numbers 1, 2, 3, on and up forever. They're the numbers that you first learned how to count. And these form the fundamental building block of the real number system. So, in fact, if you take all of the natural numbers, pull out a shape here. If you take all of the natural numbers and add on to that zero and the negatives of all of these natural numbers, what you get are the integers. So the integers consist of all of the natural numbers 1, 2, and 3, and 4, on and up forever, and 0, and the negatives of each of these natural numbers. Okay? A very common misconception is that the integers are just the negatives. Oops, there should be a negative 3. And that's actually not true. The integers are all of the natural numbers. So 1 is an integer, 2 is an integer, 3 is an integer, as is -1 and -2 and -3. Okay? Now, if you take those integers, let's get rid of that text. There we go. If you take all of those integers and put them into fractions, what you get are the rational numbers. All right, so the rational numbers are all of the fractions of integers. So take any integer and put it in interaction with another integer, and that's a rational number. This includes all fractions, obviously, but also all terminating and repeating decimals. Because if you can convert any fraction that's a fraction of integers, you'll get if you convert that to a decimal, you'll get either a terminating or repeating decimal. Okay. Now, once again, we have this containment. So any natural number is also an integer, and it's also a rational number, because I can take any one of these. I can take any natural number like 3 and put it over 1, and now it's a fraction. I can take any like -2 and put it over 1, and now it's a fraction. So all of these integers and natural numbers are also fractions, and so therefore they are also terminating decimals, because their decimal doesn't go on forever. So this is 1/2 of the real number system, and you can see the containment. Any natural number is also an integer. Any integer is also a rational number. The only other thing we have to cover are the irrational numbers. Okay, the irrational numbers are, let me put this in bold here, the irrational numbers are non-terminating, non-repeating decimals. So things like the square root of 2 or the square root of 3, but not the square root of 4, because the square root of 4 is 2. Any root that doesn't work out perfectly is in an irrational number. You can also think of pi as an irrational number, even though it technically isn't. Pi is actually called transcendental, but the differences aren't worth talking about here. This is a non-terminating, non-repeating decimal, like the square root of 2 and the square root of 3. This together forms the real number system. These irrational numbers are a big glob of chaos. It's all non-terminating, non-repeating decimals without a lot of rhyme or reason, roots that don't work out evenly. Pi. There's another number called e that we will learn about later. That's irrational numbers. But over here in the rationals, we have these nice layers of containment. The natural numbers are contained within the integers. They're used to construct the integers. So every natural number is also an integer, and then every integer is also a rational number. Okay, and so if we look at the worksheet for today, where you have to classify all of these numbers as either natural. Don't worry about whole. In fact, you can X that out. Integer, rational, or irrational. These symbols N, Z, and Q are part of the traditional markings for integer and rational. I forget precisely the origin of each of these, but like if you look at -8, -8 is an integer, so you put Z. But -8 is because it's an integer, it's also rational. So because of the containment that we talked about, anything that you classify as an integer will also get classified as a rational number. Fractions are rational. Terminating decimals are rational. Be careful though, because like 21/3 is 7, which is natural. So this is a natural number, therefore it's an integer, therefore it's rational. Okay, so as you complete this worksheet, you need to think about two things. Think about what the number actually is, and also think about the layers of containment. Okay, especially over here in the natural numbers. All right. Thank you so much for listening, and we'll pick this up tomorrow.